Hello everyone. Welcome to Python, Performing Transportation Network Analysis. My name is Melinda Morang, and I'm here with my colleague Max Zheng. We're product engineers on the network analyst team, and we're very excited to be talking to you about this today. Before we get started, we realize that it can be quite difficult to follow along with code in a presentation like this, so all of the code samples as well as these slides are available for download at this address. Go ahead and take a moment to make a note of it, and we'll show it again at the end in case you miss it. Today we're going to start off with a brief introduction to Network Analyst. Then we'll talk about network analysis with Python in ArcGIS Pro using the arcpy.nax module, which includes the arcpy.nax solver classes, as well as the arcpy.nax network dataset class. Then we'll talk about network analysis using web services with the ArcGIS API for Python. So let's start with an introduction to Network Analyst. The ArcGIS Network Analyst extension is the part of the software that's for solving transportation analysis problems. There are tools for assessing the coverage of different facilities, for optimizing things like site location and fleets of vehicles, and for point-to-point routing, such as how do I get from point A to point B, what's the closest facility, and for solving origin-destination cost matrices. Underlying all Network Analyst workflows is a network dataset. This is a dataset that includes street features as well as attributes describing travel times and distances, restrictions for travel, etc. When you perform an analysis, you have to choose which network you want to use to perform the network analysis calculation. Even if you're using ArcGIS Online or Enterprise routing services, there's still a network dataset underlying the calculations in those analyses. You've simply chosen to use the service as your network data source, and the service itself uses a network dataset that it got published with. Where do you get a network dataset? You can purchase StreetMap Premium, which includes a high-quality network dataset for your selected country or region. You can also purchase the StreetMap Premium Custom Roads product, which includes the StreetMap Premium data, as well as the flexibility to add your own roads or attributes into the dataset. You can build your own network dataset using your organization's data. There's some help available if you're a local government trying to build a network dataset from your street center lines. You can also use other data sources like Tiger or OpenStreetMap, although the data quality often isn't great and it will sometimes require a lot of work. Also, you might not need your own network dataset at all. You can use the ArcGIS Online services to perform your network analysis calculations. Those services use the same data as StreetMap Premium, but you don't have to own the data. You just pay service credits and let the servers do the work for you using the data that lives there. You have two main options for doing network analysis with Python. First is the arcpy.nax or nax module in ArcGIS Pro. Second is the ArcGIS API for Python. This table will help you decide which one is more appropriate for your needs. First, you should consider what network you want to use to solve the analysis. If you just want to use the ArcGIS Online Network Analysis services or enterprise services published by your organization, you can use either one. However, if you want to use your own street data on your own machine, you'll need to use arcpy.nax. Next, consider what software you have access to. If you have ArcGIS Pro, you should use arcpy.nax. But if you don't, then you might want to go with the ArcGIS API for Python. Note that if you're going to use your own street data in ArcGIS Pro, you'll also need the Network Analyst extension license. Finally, a few other considerations. In either case, if you're going to use the ArcGIS Online services, you will consume service credits, and you'll also hit some analysis limits, such as the maximum number of inputs allowed. If the credit consumption or the service limits are going to be a substantial challenge for your analysis, you might want to consider whether it's worth purchasing or building your own network dataset and solving the problems locally in ArcGIS Pro. In this presentation, we'll talk about both of these options, but we're going to spend a lot more time on the arcpy.nax module and just briefly touch on the ArcGIS API for Python at the end. If you've decided at this point that the ArcGIS API for Python is the right one for you, feel free to skip ahead. With that, let's move on to talk about how to do network analysis in Python in ArcGIS Pro. So the best way to do network analysis in Python in ArcGIS Pro is to use the arcpy.nax module. This Python module provides easy-to-use classes and methods for performing network analysis and accessing the network dataset. This module was added in ArcGIS Pro 2.4. Note that it is not available in ArcMap. If you've worked with Network Analyst in Python in the past, you might be wondering what happened to arcpy.na? That module is still there, and it still works. However, at ArcGIS Pro 2.4, we added the new arcpy.nax module. This module makes network analysis faster, and the syntax for using it is more Pythonic. It's really easier to use. In the example shown here, I solved a simple service area calculation using both modules. First, I solved it with arcpy.na, and it took about 11 seconds. Then I solved the same analysis with the same data using arcpy.nax, and the runtime was under 2 seconds. So we recommend using this new module for performing network analysis with Python in most cases. Note that for small problems, there really is quite a large difference in runtime, but as the problems become larger, that difference kind of evens out. You'll still need to use arcpy.na if you need to work with network analyst layers for some reason, if you're going to publish a map service with network analysis capabilities, or you need your script to be compatible with ArcMap or older versions of ArcGIS Pro. There's some documentation available that explains this in more detail, and there's a link here on the slide. For the rest of this presentation, we'll be focusing on the capabilities of arcpy.nax. Let's dive into arcpy.nax. This is a summary of the workflow that you'll want to use for performing a network analysis, such as calculating a route or a service area. First, you initialize the analysis object, which is based on a specific network data source. Then you set the properties for the analysis, you load the inputs, and then you solve the analysis, and finally you access and work with the results. Each type of network analysis, or solver, has its own Python class. When you instantiate the solver object, you need to set the network data source. This can be either a network dataset or a URL to a service, such as ArcGIS Online or a service running on your own portal. When you instantiate the solver object class, you can set the various properties. You can see on the slide here a long list of available properties for the service area solver object, such as the travel mode and various properties for fine-tuning the output polygons. The class has methods for loading data as well as solving and some other helper methods. When you solve the analysis using the solve method, it creates an instance of a result object for a particular solver. You can access the analysis results from that result object. Now I'm going to hand it over to Max, and he's going to demonstrate this basic arcpy.nax workflow in a sample script.
Thank you, Melinda. Today I will be showing you some demos using our next generation Python API for network analysis, which we call the NAX module. To me, it is a better designed API, easier to understand, and more Pythonic. Also, you get better performance. Now, let's jump into the first demo. So for the first demo, I'm going to show you a simple route workflow where we just try to find the route between the 3 depots in San Francisco area. And I will debug this code to show you the 5 steps that Melinda was just mentioning. So here we have some setups going on here, and our network data source comes from the San Francisco geodatabase. And at this breakpoint, we first initialize our route object. This is our first step. Second step is to set your properties for your analysis. There are a lot of properties you can set on your analysis to fine-tune your route. But the important one I want to highlight here is travel mode. Here we can call getTravelMode on our network dataset to get travel modes supported on the network dataset. It returns you a dictionary where the key is the travel mode name and the value is the travel mode object. And from this dictionary, we get the driving time travel mode. And then we can set our route object's travel mode property to this driving time travel mode. Then we call load function to add input data into my route object. The first parameter takes the input data type. Here, we specify the input data type of stops using an enumeration. You can find we use a lot of enumeration in our NAX API. It is just a set of symbolic names representing some of the constant values. And we use these enumerations just because it makes it easier to use and to understand. Then we can call the solve function our route object, and it returns us a route result object. There are some properties on the result object and some methods to work with the result. For example, there is a solve succeeded property, and it returns you whether the solve succeeded. If it's not succeeded, then we can print out our solve linear messages. And if it succeeded, we can export our route result to the in-memory feature class. Here, the output data type is also an enumeration. Then the rest of the code is to use a generic arcpy search cursor to get the name and total distance from our route. And we can get it running. And here on the terminal, we can see this is our route name and this is the total distance. One more thing I want to show you in this demo is when we design these Next APIs, we have in mind that it should be easy to work with the routing services. So if you want to run your analysis with routing services, all you need to do is to change how you initialize your solver object from using a network dataset to a portal URL. So here we comment out the part where it's getting the network data source from the FileGeo database, and we comment this part to get the network data source from the portal URL. Everything else stays exactly the same, and we can run this analysis. So one thing I want to mention here, of course, you will need to sign in to ArcGIS Online so that we know the token to get rerouting services. Here, because we have already signed in to ArcGIS Online in our Pro, so it knows where to get the token. If you haven't signed in to ArcGIS Online, then you need to provide the username and password and call sign in to portal before using arcpy.nax API with the routing services. And we can see the result comes back to our terminal. This is our route name and this is our total distance. The total distance is slightly different because the data used in online is different than the data we used here in our example. So throughout this demo, you can see the ease of using Next API. You create a solver object, you set properties for your analysis, you load some input data, you solve your analysis, and then you work with your result object. So hopefully this gives you an overview of this API and how to use it. Back to you, Melinda.
Thanks, Max. One of the most important parts of your network analysis is loading inputs and accessing outputs. There are a couple of ways to do that, and the right choice depends on your situation. I'll summarize these now and then talk about some of them in more detail later. For loading inputs, you have a choice between loading an existing feature class using the load method or directly inserting inputs using the insert cursor method. For accessing outputs, you can export the results to a feature class using the export method or directly access the outputs using the search cursor method. If you want to debug problems in your analysis in the map, you can use save as layer file and then add the layer to the map in ArcGIS Pro. If you want to create a zip file containing route data suitable for use in Navigator, you can use the save route data method. The solver objects have various types of inputs and outputs, and each of those has a particular schema. For example, surface area inputs include facilities and optional barriers, and the outputs include polygons, lines, and a copy of the facilities. Each of these has a specific schema. You can read more about these in the documentation. There's a link in the slide. If your inputs are already in a feature class, the easiest way to use them in the analysis is probably with the load method. If you have fields that you care about in the input feature class, you'll need to use the field mappings method to create a field mapping object so you can associate the field names in your input data with the field names used by the schema for the network analysis. For example, the vehicle routing problem solver's input orders class has a field called service time. This field specifies the amount of time the driver will spend at each location. For example, if the driver is making a delivery, the service time is the time to actually make the delivery. However, that field in your input data might not be called service time, but it might be called something else, like delivery delay. You can use field mapping to map your delivery delay field into the VRP orders class's service time field. Again, you'll want to look at the documentation to see what fields are supported for the analysis type that you're using. For accessing outputs, the result object's export method is quite straightforward. It basically just saves the analysis results to a feature class that you specify, and it includes all the output fields. The schema of these outputs is also defined for each output of each analysis type. You can learn more from the same link that we showed earlier on the previous page in the documentation. Now I'll hand it back to Max to show you an example of using load with field mapping.
Thank you, Melinda. So the demo that we are looking at here solves the vehicle routing problem. We want to plan route for a truck starting at the depot and deliver it to all the stores. And while we are looking at the code, let's get it running. So in this demo, one of the things I'm doing differently is first I'm making a network dataset layer from this network dataset catalog path And then I'm using the network dataset layer name to initialize my VRP object. And this is the performance trick that Melinda will explain to you later. Next, we are setting the properties for our analysis. So for this particular analysis, we are setting our time units to be minutes and distance units to be miles. This is the units we'll be using for our inputs and outputs. And for the route shape type, we want set it to be true shape because we want to visualize it on the map. And for the stops, we want to visualize the sequence to visit, so we want to set return stop shape to be true. So in a real-world scenario, here you might want to connect to an external information system. Probably is your external database where you get your orders, depots, and routes for the day, and feed it into our vehicle routing problem solver to do the analysis. And after you get your result back, you can update the information system with your result. Here we just simplify the demo, and our orders, depots, and routes come from a feature class in a file geodatabase. So on our input data, we have a field called delivery delay, and our orders, we have a field called service time. They essentially mean the same thing, and they are used to model the time it takes to deliver at the stores. So for example, delivery grill takes different time than delivery TV. Since the field name isn't the same, we need to get into the business of field mappings. So as Melinda mentioned, we couldn't know all the field names, so we have predefined schema for our inputs. And you need to map the fields to our input schema so they can be used in analysis. This is what we call field mappings. And for any of the input data, we can ask the field mappings from the solver object. For example, here, we are asking the VRP to give us the field mappings for the orders. And it will return me a dictionary where the keys will be the field names of my orders, and the values will be the field map object. And once I get the field map object, I can then specify the mapped field name and the default value. For example, here, we are mapping the delivery delay to service time, and we are setting the default value to be 10 minutes. And we know here it is 10 minutes instead of 10 hours because we set our time units to be minutes. Next, we load the orders, depots, and routes into our VRP analysis. When we load our orders, we set the field mappings we just defined. And once we get our result after we solve it, we can export the stops and routes, and we can look at it in the map. Here is our result. This is how our vehicle starts at the depot, visit all the stores in the sequence, and then return to our depot. So in some cases, you might want to take what we have visualized in the map and send it to the drivers. And what we can do here is to create a route layer in your active portal and then send this route layer to your driver. And to do this workflow, you can ask the VRP result object to save the route data. And it's essentially a zip file that contains all the route information. And this zip file can be used as the input for your share route layer function. And this share route layer function is going to create a route layer in your active portal. In my case, my active portal is ArcGIS Online. And this is the route layer, and we can take a look at it. So this route layer item has this ArcGIS Navigator link. And you can get this ArcGIS Navigator link and send to your driver. And your driver will be able to open this route layer in the ArcGIS Navigator app. So this is the workflow how you can pre-plan the day's delivery work using vehicle routing problem analysis, and then send this analysis result to field worker so they can follow the pre-planned route. Back to you, Melinda.
If you're getting your inputs from something other than a feature class, such as a CSV file with latitude and longitude, or the results of some other analysis, you can directly insert these into your network analysis using the solver object's insert cursor method. This method isn't the same as the arcpy.da.insert cursor, but it behaves in a very similar way. The search cursor method on the result object can be used to directly access the outputs. It's useful if you only care about a couple of output fields. For example, in an OD cost matrix analysis, maybe you just need the travel time between each origin and each destination, and you're going to post-process that into some other format. You don't need to write the entire results table to disk, just get that one field. Search cursor is a method on the solver result object and you can choose which fields to access and then iterate over the results. It's not the same as the arcpy.da.search cursor method, but it's quite similar. Now I'll hand it back to Max, and he'll show you an example using inputs and outputs with cursors.
Thank you, Melinda. So I have two demos to show you how to use cursors to work with input and output. The first one is another route. This time, instead of getting inputs from feature class, I'm using insert cursor to insert my stops. And let's get it started. So first, we initialize our route object. So this time, I want to solve a route from home to work starting now and get the directions. So for the analysis input, I set my time of day to be now and set directions to be true. Since I don't have my home and work locations loaded into a feature class, so I'm using a cursor to add them to my input stops. Here, I'm opening an insert cursor on my input stops. I'm just going to provide the name and XYs. And here we are calling the insert row twice to insert the home with XY and work with XY. This tuple is just an easy way to pass in the longitude and latitude that indicate the location. So this insert cursor is just an easy way to insert your data directly into the solver object without doing a data format transfer. And then when we solve it, once the solve succeeded, we just want to get some information from the directions. So here, we are just opening a search cursor on our output directions to get the arrive time and the turn-by-turn directions text, and we print it in the console. Here on the right side, we can see this is our route from home to work, and this is our turn-by-turn directions and when we'll arrive at each of the directions maneuver. If we don't have the search cursor on our result, then when we want to get some information, we will first need to export the result into a feature class and then open an arcpy search cursor on the exported feature class to access the information, which is a lot of work. So the cursors on the input and output is really made for you to insert or access the output data easily and quickly. So one more cursor example here, and let's get it running. So in this example, we are trying to find the total time and total distance between a couple hundred locations in San Francisco area. And our input data comes from this addresses.csv. And let's take a look at it. All we have is the longitude and latitude and the name of each of the address. And if we were to look at it on the map, here are our couple hundred points in San Francisco area. We just want to find the total time and total distance between all of them. So this is a typical origin-destination cost matrix problem. So to solve this analysis, we can first initialize an origin-destination cost matrix solver object. And for this example, we are setting our time units to be seconds and distance units to be feet. As you can see on the map, they are pretty close to each other. And our locations comes from the San Francisco.csv as we explained. And here we open one insert cursor on the origins and one insert cursor on the destinations. For the inputs, I'm only providing the name and shape XY. So one thing I want to mention here, it's better to use a wait statement for the insert cursor to better manage the life cycle of the cursors. So here we open a CSV using a Python generic CSV reader, and we skip the header row, and for each of the row, we just read the longitude, latitude, and name of the address. And then we insert the name and the XYs into the origins and destinations. And then we solve our analysis. For the result, we want it to write into a lines.csv as our output. And for the output, we only care about origin ID and destination ID and what is the total time and total distance between each of the origin and destinations. So these are the fields that we will search on our output. So here, we open our output file and we start a generic CSV reader. And we write those fields that we care about into the header. So for the output lines, we search for the fields that we care about. So one special logic here is if the origin and destination is the same, we'll skip writing this row, because in our case, origins and destinations come from the same point. So in this case, we know the total time and total distance is going to be 0. And let's take a look at our output line in CSV. So here we can see from origin 1 to destination 42, this is the total seconds and this is the total feet. So these two examples shows you how to use the insert cursor and search cursor on the input and output to easily work with solver object. Back to you, Melinda.
Now I'm going to talk about a few tips and tricks for improving your analyses. Unlike the old arcpy.na workflows, arcpy.nax gives you control over the units that your results are reported in. You can use the time units and distance units properties on the solver object to specify which units you want. Behind the scenes, Network Analyst calculates the results using the impedance attribute associated with the travel mode you selected, but then it converts the units of that impedance attribute into your desired output units before reporting the results to you. This tip is for a performance improvement. You should use a network dataset layer instead of a catalog path to a network dataset in your script. If you use a catalog path, the script has to open the network dataset behind the scenes every time it references that catalog path, and this can be especially slow if you're using licensed data or data on a UNC path. If you instead use the Make Network Dataset Layer tool to open the network once and then pass in that layer by referring to its name in other tools that use the network dataset, that can give you a bit of a performance improvement. For example, if you run the getTravelModes function and then instantiate a solver object class, this would have to open the network dataset twice if you use a catalog path, but only once if you use a network dataset layer. Now we're going to talk about the network dataset class in the arcpy.nax module. Recall that underlying all network analyst workflows is a network dataset. This is a dataset that includes the street features and also attributes describing travel times and distances, restrictions for travel, etc. arcpy.nax has a network dataset class that allows you to access the network dataset properties and components. You can get some basic information, such as whether or not the network dataset is currently built. More interestingly, you can access the network's edges, junctions, and turns and get information about attribute values and connectivity for each one. You can even optionally specify a time of day and travel mode, which may affect the values returned. You can iterate over the edges, junctions, and turns and use this to construct your own network analyses to solve problem types that are not available with the Network Analyst extension out of the box. Here's a representation of the network dataset class. The edges, junctions, and turns methods are the most important. Each of these returns a cursor object, so you can iterate through all of the network dataset's edges, junctions, or turns. When you call the method, you can specify which properties and network attributes you want to get the value of. For example, for an edge cursor, you can get information such as the from junction and to junction, which are the IDs of the junctions connected at either end of the edge. You can also get the values of network attributes, such as the restrictions or impedance values, like travel time, for an edge. If you specify a travel mode, you can use isRestricted to determine whether or not the edge is restricted when that travel mode is being used in an analysis. Note that the ability to specify a travel mode and to retrieve the summarized cost, time, distance, and isRestricted properties is new in ArcGIS Pro 2.7. So how could you use this functionality? You can construct a network dataset in ArcGIS, and then you can use the network dataset class to export the network graph to other formats. You can use the network graph if you're writing your own graphing algorithms or using graphing algorithms available in other libraries, such as the third-party NetworkX package. To see an example of this, you can download the Find Network Subgraphs tool. This sample script tool we created helps you identify areas of your network dataset that are disconnected from the rest. It does this by exporting the network dataset graph into a NetworkX graph and using NetworkX's connected components method to find the subgraphs. Max is going to show you a little bit of this in the next demo. All right, now I'm going to hand it over to Max to talk about the network dataset class and show you some examples.
Thank you, Melinda. I have two samples to show here. The first one is to going through all the edges in my network dataset and sum up some information and print out some interesting status. This is just a simple example to show the concept, and let's get it running. So to do this, the first thing I'm doing is to initialize a network dataset object based on my network dataset layer name. Then I just have a few variables to store my accumulation result here. And all the magic is happening here. This iterator goes through all the edges in my network dataset and want to get the meters and one-way attribute on my edges. So now I can sum up the total distance, count the edges in my network dataset, and if the edge is one way, then I count it separately. So on my terminal, I can see the total distance of my network edges is 12,000 kilometers. So this is the distance if you were to drive a car for every street in San Francisco, both directions. That's the mileage we will be adding on to your vehicle. And the total edge count is this number and one way is this number. So our one-way streets percentage is 70%. So does it mean 70% of streets are one-way in San Francisco? It is not, because when we are counting one-way streets, we also include freeway segments that are one-way. Next, I'm gonna show you a more advanced usage of this network dataset class. For this example, I'm gonna show you a script tool that Melinda wrote to help find disconnected portions of your network dataset. I'm gonna come back to the script a little bit later, since this is a script tool, so I want to show you how to run it in Pro. So here, this is a script tool. It takes a network dataset as an input parameter, and we can specify the network dataset layer we have in the map, and we can get it running. And while this is running, let's take a look at the code. So here, it imports network X as Melinda talked about. This is what we are going to use for our analysis. Like prior examples, first thing I want to do here is to initialize my network dataset object. This tool requires the network dataset to be built, so here we are checking whether a network dataset has been built, and if not, we exit out directly. Here we have some setup going on here to create a temporary table to store the subgraphs. This is the important part. We are creating a network X multigraph. This is the graph that we are going to use for our connected analysis in network X. And the meat of the code is here. It reiterates all the edges in my network dataset, gets some of the properties that we care about, and then it inserts the edges from my network dataset into the network X graph that we just created. So this essentially transforms the network dataset into a network X graph. Here on the network X graph, we just call the connected components analysis on the network X package. If the number of connected components is 1, it means everything is connected. If not, then we symbolize the portions that is not connected to the other part of the graph. So let's take a look at the result in Pro. So as we are showing here, the gray part is the main graph, and the red ones are not connected to the gray part. So not too surprisingly, when we clip out this tutorial network dataset from a much larger network dataset, so we end up with some disconnected streets around the outside. You might find this tool handy for some of your QA for your data. And in the same downloadable link that Melinda showed you how to get to this tool, we have a version 2 of this tool which takes in a travel mode. So this connectivity analysis will take your travel mode, for example, one-way information in your data into consideration when we do this subgraph analysis. So one thing I want to mention here is we couldn't do this analysis for a large nationwide network dataset because it is just going to run out of memory. This is just some constraints of what network X can handle in memory. But the idea here we are trying to convey is now it is possible to export your network dataset into some other system and then make use of the algorithms that are available in the other system. And all of this is made possible when you are using the network dataset class. Back to you, Melinda.
Now we're going to move away from talking about arcpy.nax in Pro, and we're going to transition to talking about network analysts with web services using the arcgis API for Python. The ArcGIS API for Python is a Pythonic API for working with ArcGIS Online or ArcGIS Enterprise services. To use this, you don't need ArcGIS Pro on your machine because it works entirely through web services. It's also designed to work nicely with Jupyter notebooks and is available out of the box in ArcGIS notebooks. The ArcGIS API for Python includes network analysis capabilities that can be accessed in more than one way, through the network.analysis methods and through the features.analysis methods. These do very similar things. The network.analysis methods are faster and give you access to the full range of network analysis capabilities. The outputs are feature collections only. The features.analysis methods are designed for WebGIS workflows and can use feature services or feature collections for inputs and outputs. We aren't going to go into this in great detail in this presentation, For more information, we suggest that you do the tutorials. There's a link here in the slide. There are a couple of other workshops at Dev Summit this year that cover some of the other aspects of the ArcGIS API for Python also. They probably won't be doing any network analysis, but it can help you to get started with the API in general so that you'll be ready to tackle those tutorials. Also, feel free to download and play around with the code sample that Max is about to show. He won't be able to show you the details of absolutely everything he does in there, but you can take a look at it yourself later and learn more. All right, Max, let's go ahead and see a demo of the ArcGIS API for Python's arcgis.features.analysis module for doing network analysis with an ArcGIS notebook.
Thank you, Melinda. As Melinda just mentioned, ArcGIS Python API is included in ArcGIS Notebooks, and ArcGIS Notebooks is just a notebook hosted in ArcGIS Online. It includes lots of Python packages you will normally use in the data science field, and it also includes ArcGIS Python API to help access services provided by Esri to perform geospatial data analysis. So in this demo, I'm going to show you how to solve a workflow using ArcGIS Python API, particularly the arcgis.features package in ArcGIS Python API in ArcGIS Notebooks. So here, I sign into my ArcGIS Online account and I go to my Notebook tab. I already created a notebook to solve our analysis. And let's take a look. So for our analysis, what we are trying to do is we are trying to figure out the students that are not eligible to take school bus. Students in our school district are only eligible to ride the school bus if they live more than 1 mile's walking distance away from the school they attend. And to determine which students are eligible to take the bus, the school district needs to calculate the walking distance between each student's home and the assigned school. And for our analysis input, we'll have two CSVs, and we can take a look at those CSVs. We have a school CSV, which has the school's name and the address of the school. And we have the student CSV, which has the name of the students, the school it attends, which has the same values as the name of the school, and the address of the student's home address. So for our analysis, we just want to calculate from each student's home address to our school's address that it's assigned to and calculate the walking distance between each pair. So for this analysis, theoretically we could call our findRoutes tool several times to find the walking distance between each student and the schools it attends. But there is a better way to do it, which is using the arcgis.features.analysis and use the connect origins to destinations tool to solve our analysis. So to use ArcGIS Python API, the first thing you do is to initialize the GIS object. Normally you initialize with portal URL, username, and password, but since here we are using ArcGIS Notebook, we can just initialize GIS object using the home, where it gets a username and password and sign-in token from your signed-in ArcGIS Online account. Next, we upload our CSV into our system. So to do that, we can go to Files, ArcGIS, Home, and we can use Choose Files to upload our local CSV into our system. And once we have the CSV into our system, what we can do is we can just call add to notebook. And it's going to add our CSV into the notebook. And let's just delete it because I have already done this part. These two steps is essentially what I was just explaining. Next, we read the CSV into the pandas and geocode by the address field. We can take a look at our inputs once we get them into our spatial data frame. So we have the schools and the address and the location, and we have the students, the school they attend to, address and the location. And we can display our students and schools location on the map. Here are the 3 schools and here are the 9 students that we have. So the tool that we are going to use to solve our analysis is called Connect Origins to Destinations, where it's trying to connect origins to destinations using a matching ID field. So in our case, we are trying to connect the students to the school they attend to, and we are trying to use the walking distance as the travel mode. And in our origins layer, which is the students, we have a field called school, which indicates the school it attends to. And our destination layer, it has the ID field called name, which indicates the name of the school. And we can use the matching ID field to match each of the students to its matching school. And for the output route shape, we can use straight lines so that it's easy to visualize which students go to which school. We can inspect our results. It's a dictionary. These are the keys of our output. And for this analysis, we only care about the route layer's output. And we can display it on the map, and we can see which student goes to which school. To figure out the distance between each student to its assigned school, what we can do is we can query the output routes and display the spatial data frame and sort by the total miles, which is the distance between each student and the school. And it has a lot of data, which is not very easy to visualize. So what we can do here is we can draw a bar chart where the x-axis is the student's name and the y-axis is the total miles. And we can also draw a line that indicates 1 mile, which is the cutoff that the student is eligible to take the school bus. So here it's easy to show these 3 students are not qualified. And finally, we can display the student's name that are unqualified and also the total distance that it needs to walk to the school. So in this demo, I'm showing you how to use Connect Origins to Destinations tool to solve a particular analysis issue. And I showed you how to use it in ArcGIS Notebook to do this kind of ad hoc analysis. Back to you, Melinda.
Thanks, Max. All right, let's wrap up our presentation. To summarize what we've talked about today, the arcpy.nax solver objects can be used to perform network analysis in ArcGIS Pro, using local data or a service, and for writing scripts and script tools. The arcpy.nax.network dataset class can be used to access network graphs and extend the network analysis capabilities. The ArcGIS API for Python is for performing network analysis using web services without ArcGIS Pro. And you can either use the arcgis.network.analysis or the arcgis.features.analysis modules. Here again are some resources for you. The arcpy.nax documentation is a great place to go for more code samples and details on how that module works. And again, you can download the slides and code that we showed today from this address. Thank you for attending our presentation. Please provide your feedback for this session by clicking on the session survey link directly below the video. Hello, everyone. My name is Melinda Meringue. I'm here with my colleague, Max. Thanks a lot for attending our session. We're going to do some Q&A now, so I'll start with some questions that have come in throughout the presentation, but feel free to continue asking questions in the chat. So we have a question about what, if anything, are the differences between the arcpy.da cursors and the insert and search cursor that's on the solver objects. And basically they do the same thing. You can use them to either insert something row by row or access the outputs row by row. The arcpy.da cursors are meant for interacting with feature classes and tables that are on disk and already exist, whereas the solver cursors are meant for interacting specifically with the arcpy.nax solver objects. The DA cursors have a couple of extra bells and whistles that we don't have in the solver cursors, like the ability to specify the spatial reference and use a datum transformation. But other than that, they're basically meant to do the same thing. Max, you want to take a question?
Sure. So there is a question about recognizing arcpy.nax doesn't support network analysis layers directly. Does Nex fully support the same set of properties and inputs for the solve route operation? In other words, is it the same process, but just a different implementation? The short answer is yes. So if you are familiar with arcpy.na module, what our previous workflow is you first call arcpy.na make route analysis layer, and then you will be able to provide a set of settings on your analysis layer. And then you code allocations to add your input to the internal route stops feature class, and then you can call the solve function to solve them. The arcpy.nax API is using the solver object to give you the same workflow. It's instead of making a layer, it initializes a solver object, and you will be able to set the same set of properties and also loads the input data, do the field mapping, all those things, and also directly call the solve method on the route object. So essentially, we are making sure the things that you are able to achieve using arcpy.na is also achievable using arcpy.nax using the solver object.
There's a question here about the best way to get solver results from into a pandas data frame. That's actually super easy with the search cursor on the solver result. The search cursor just produces an iterator, and you can directly use an iterator when instantiating a data frame. So if you are able to see the response that I left to that question in the chat, the formatting is completely terrible because there is no formatting in this chat product thing. But basically, if you do a search cursor on the result object, you get the cursor object, and then you can just do pandas.dataframe and then use that cursor object and specify the columns you want, and then you got a data frame.
Okay, so we have a question from Drew. Just to confirm, the ArcGIS API for Python solvers must use the AGOL network dataset and so must consume credits. Is that correct? So the ArcGIS API for Python is essentially calling a REST API. So it can be initialized with ArcGIS Online AGOL user URL, or if you have your portal that publish the routing services directly on your enterprise, then you will be able to initialize ArcGIS API for Python using that portal. And then all the routing analysis will be coming from your own routing services. In that case, it wouldn't consume any credits. It will just use the routing services that you published on your server and that is federated with your ArcGIS portal. And go ahead.
We've had a couple questions about traffic or trash pickup, snow plows, and stuff like that. That's the vehicle routing problem solver, although it isn't really optimized to do that sort of thing. But there is a another session that you can attend, and I will add a link here. Let me make this public, this question public. All right. You can answer another question, Max. I'm just going to type a reply in here for people that are interested in this type of thing.
Sounds good. So there is a question about whether there is ArcGIS notebooks for ArcGIS Enterprise, and the notebook would be hosted not by ArcGIS Online, but by ArcGIS Enterprise. And the short answer is yes, there is a notebook for ArcGIS Enterprise. And from the reply, you will see I pasted some generic information for where you can find more about ArcGIS notebooks for ArcGIS Enterprise. But both of us are not experts in this area. So if you have additional specific questions about running notebooks for ArcGIS Enterprise, the license and everything about it, you can go to Ask Our Experts. There is a ArcGIS Enterprise area. You will be able to ask in there, and there will be a specialist that is working in this area.
There was a question about the memory usage of arcpy.nax compared to network analysis layers, and also the performance difference. And so, yeah, one of the reasons that the arcpy.nax stuff is faster is because it's using in-memory solves rather than lots of disk read-write, and also because it eliminates the overhead of running geoprocessing tools. So that can sometimes stack up. But yeah, because it's running in memory, it does have the potential to use a lot more memory than the layer-based workflows.
So I have a question coming in. Is there any practical limit on the spatial data network size of the network data set stored in ArcGIS Enterprise? Like, could I create a US-wide network data set in ArcGIS Enterprise and use it for no credits network analysis all across the country? Yes, if you have a network data set for the whole North America, you will be able to publish your own routing services. There is a utility called publish routing services utility, where you can publish the routing services and you will be registering the services on your enterprise as well. So once you have the routing services published and registered with the portal, you will be able to use ArcGIS Python API to use that portal and do the routing services. You will use your own services that you published. In fact, we also have another session this morning that talks about the workflow of publish your own routing services on your enterprise. I will try to find the link to that session, and you might be able to view more information about how to do that workflow.
There's a question here that says, will the same network analysis problem typically be faster to solve using arcpy.nax or arcgis.network.analysis? Actually, I thought this was a different question, and now I'm not sure what the answer is. Max, do you know? NAX versus the ArcGIS Python API?
So will the same network analysis problem typically be faster to solve using arcpy.nax or arcpy.network.analysis? So it depends. So first, if your analysis is happening locally, then there's no way you can use arcgis.network.analysis. That means if your data is on your disk, you can only initialize a solver object using arcpy.nax with your own data on the disk to do your analysis. But if you are accessing the service to do your analysis, the performance would be similar between using arcpy.nax versus using arcgis.network.analysis, the ArcGIS Python API package. But there are certain limitations. You cannot use arcgis.network.analysis because it's purely based on REST. So if your analysis is returning a very large result, it might not work very well in the arcgis.network.analysis API. But arcpy.nax is using binary SOAP. So it is actually being able to solve larger problems for your analysis.
Well, it looks like we have about 2 minutes left in our session. So if you want to ask us a question, ask now, or if you can't think of anything in the next 2 minutes, you can ask in the ArcGIS Pro channel in the Ask the Experts area if you want to talk to us later. Oh, here's a question. Okay, there's a question here about what's actually in the solver.result object, and can you use that to get the edge objects that were involved in the solution? So the first half of the question is like, what's in the solver result object? It depends on the solver, and it's the same sort of output that you would get in the network analysis layers. So for example, if I solve a route, I can get the actual routes that were traveled. I can get the stops that were used and like when they were visited. There's a documentation page, and I'm going to paste the link into this question when I get done talking. The second part of the question is there a way to get the actual like edges of the network that were traversed? And that also depends on the solver. With route and closest facility, yes, one of the output types is like, it's called route edges, and there's another one called route junctions and route turns, and that will return the segment by segment edges of the network that were traversed by that route. Some of the other solvers like service area and OD cost matrix and location allocation don't allow you to do that because they just don't store that information.
Okay, I think we are approaching the time for our session. Thank you very much for coming. And if you have other questions you want to follow up with us, you can come to ArcGIS Pro Ask Our Experts section and ask to talk with us. Thank you very much.